Hi, in this Let's Create series, we're implementing the core game mechanic of a range of simple games. In this episode, we're going to do Minesweeper like this. We've got flagging, auto expansion of blank squares, and the wonderful double click mechanic. Let's get started.
For this project, we're going to create a standard Unity 2D project called Minesweeper. First of all, we need to add our sprites to Unity. So create a new folder called sprites, and we'll drag in all the sprites we're going to need for this. You can download a zip file of them all from the description below. Here we have the numbers 1 to 8, an empty tile for when there are no mines nearby, the flag for marking suspected mines, the mine, the red mine appears when you click on it by mistake, and the unclicked square, which is how the game starts. Finally, the wrong mine. This is used if you flagged an incorrect space. All the sprites I'm using here are 32 pixels square. We want them to take up half a unit, which will let us have a game board of a reasonable size. So if we select them all and set the pixels per unit to 64, then they'll be the size we want. Minesweeper is a grid of cells, so it makes sense to start by creating a single tile. Right-click, 2D object, sprites, then square. We'll change the default sprite to our unclicked image by dragging that into the sprite renderer. There's two things we'll want to add to the tile. First, we'll add a box collider 2D so that we'll be able to detect clicks on the sprite. Set the size to 0.5 to match the same size as the sprite if it isn't already. Then we'll create a new directory called scripts and add a new C# script called tile. Drag that onto the tile to assign it. Let's jump into the code. The first thing we want to get sorted is getting references to each of the sprites. We'll use a header to group these together in the inspector called tile sprites. Then we'll need various variables to hold everything in. These will all be private, but with the serialized field attribute so you can set them in the inspector. We have the base unclicked tile, which is how the game board starts. Then we'll have the flag tile, which appears when you right click. Next we have a list of clicked tiles. This will be the blank tile, followed by the numbers 1 to 8. Finally, we have the three mine-related sprites. Mine tile, mine wrong tile, where it has the red X for when it was marked incorrectly, and mine hit tile, with the red background when you click on it. There will be a few helper variables to track the state we're in, which we'll add as we go along. The first thing we need is to get a reference to the sprite renderer. So we'll add a private sprite renderer, and in the awake method, which happens right at the start, we'll assign this using getComponent, passing in the sprite renderer. We've already added this to our tile object, so we know it's there, but we can also add the required component above the class definition. By passing in typeOfSpriteRenderer, this ensures that there is a sprite renderer component attached to this. If not, it'll add one. We're going to use the onMouseOver function to check for our button presses, as we need to handle the left and right buttons pressed individually and together. We'll start with just the individual clicks. We check for the left click using getMouseButtonDown, passing in 0 to represent the left button. In this case, we'll execute our clicked tile logic, which we'll implement in a second. Then with elseIf, we'll check for right mouse button in the same way, passing in 1. This should either add or remove a flag, so we need to remember the state. So add a public flagged bool, which defaults to false. We make this public as we'll need access to this from the game manager later. So how do we use this? Well, clicking on a flag flips the state, so false goes to true and vice versa. The exclamation is used to negate a boolean in C#, so we can set flag equal to !flag, which is read as not flagged. Now we've updated the state, we can set the appropriate sprite. If it's flagged, then we set the sprite renderer sprite to the flag tile, else we'll set it to the unclicked tile. There's one extra thing we need to do here. In both of these cases, we don't want to be able to flag a tile after we've clicked it, nor keep clicking on a tile. So we'll create another public bool called active, which defaults to true to track this. So we'll wrap both of these if statements within an if active check, so that once we've clicked a tile, we don't process these clicks again. Let's sort out the click tile logic now, where we'll process the left click and set the active flag as necessary. This is a public function, as we're going to want to simulate clicks on this later. Firstly, we're going to check if the tile is active and isn't flagged. I know we already checked active in the logic within the class, but from an external call, we'll want to check again. The first thing we do is set active to false, so we don't process this anymore. Then there are two options. If it is a mine, then we'll want to set the sprite to the mine hit tile. We'll add a public boolean to hold this isMine property and default it to false. Else we'll set the sprite to one of the click tiles. To choose which one, we'll need to know how many mines there are nearby and use this to index into our list of clicked tiles. So we'll add another public variable, which is an integer called mine count, which defaults to 0. There's more to add here, but that's enough of the logic to test out that this is working. Let's jump back into Unity and set some things up. We probably should rename our square to tile. Then in the inspector, we need to add on all the sprites. To drag in the unclicked tile, the flag tile, the mine wrong tile, and the mine hit tile. We need to drag in all the remaining clicked tiles. So click the lock icon to freeze the inspector on the tile, so we can select all the other ones. We select all the numbers and the empty one and drag these in. As we're using the number of mines as the index into this list, it must be in order. So that the 0th element shows the blank tile, and say the 4th element shows the one with a 4 on it. So check what order they've been added, and if necessary, you can drag them around. We'll create a prefab out of this. So create a new prefabs folder and drag the tile in there. To test it out, we'll drag a bunch of the prefabs onto the screen. Remember to uncheck the lock icon and hit play. Now if we click on these, they'll all default to showing 0. So let's change the mine count and isMine setting of a few of them. Now let's click on them and you can see that's working beautifully. Now let's set up our game manager to create the grid and instantiate all these variables for us. So delete all the tiles from our scene. Don't worry, we still have that prefab. Create a new empty game object and call that game manager. In our scripts directory, create a new C# script called game manager and drag that onto the script. Let's focus on creating the game board first. To do this, we'll create a new method called createGameBoard, which will pass in the width and the height and the number of mines. In a full implementation, you want to attach this to a button or something, but we'll just instantiate our game from the start method. So to mirror what I think are the normal parameters for classic Minesweeper, you have a 9x9 board with 10 mines, a 16x16 board with 40 mines, or a 30x16 board with 99 mines. We'll stick with the easy implementation now, which is why I've commented out the latter two. We want to save these parameters as we'll use them in the other functions. So we'll create 3 private int variables called width, height, and num_mines to store these in. The first thing we'll do in the function is store them. We have to use this.width, etc. here because we've got the same name and there would be no other way of distinguishing them. Alternatively, you could have given them a subtly different name. This is where you may see lots of people prefixing things with an underscore. So to create the tiles, we'll iterate over the grid using a for loop over our height and width parameters. The first thing we'll do is instantiate the tile prefab, which means that we need to create a serialized private transform to pass in the tile prefab. We'll also create another transform called GameHolder because I don't like cluttering up the project with loads of objects in the root view. That means after instantiating our tile, we can assign the parent to be GameHolder so all the objects appear under there. Now we've created the object, we need to position it correctly. We can't just use the row and column indices for this, as we want the grid to be centered at 0, 0 rather than starting from it. We can sort this out by subtracting half the game width for the X and half the game height for the Y. We need a -1 in here because we want the tiles to be centered rather than offset. If this is slightly confusing, think about a 1x1 grid. The position should be 0, 0, not 0.5, 0.5. I drew out a few examples to convince myself of this, so don't worry if you have to too. Now we can't just use these X index and Y index values to place the tiles because our tiles are not 1 unit big. The sprites are half a unit wide. So create a new private read-only float called tile size with a value of 0.5. We could calculate this from the sprites directly, but we set up the sprites with this value in mind, so there's no harm in hard coding it in. The tile local position can now be set as the index times the tile size. Let's stop there and jump back into Unity and make sure that's working. Make sure the Game Manager object is selected and drag in the tile prefab. We can then create another empty game object and call that GameHolder. And we'll just reset the transform on this to make it nice and centered. Then selecting the Game Manager, we can drag our new GameHolder object onto that. As you can see, hitting play, we get the grid of tiles appearing correctly and we can click on them. We haven't got any states set yet, so they're all blank. Jump back into the Game Manager script and we'll sort that out. We need to be able to update the parameters of each of our tiles, so we need to keep a reference to them when we create them. So we'll create a private list of type tile called tile. Then our createGameBoard method, after we've finished instantiating our prefab, we'll grab the tile component from this using getComponent of type tile, and then add this to our list of tiles. What we'll do is, after creating a game board in our start method, we'll add a new method called resetGameState, where we'll put all the logic. This will enable us to easily restart the game when we win or lose. The first thing we should do is decide where the mines are going. These need to be randomly distributed around the board. One method for doing this is to randomly pick a location and set that to a mine. If it already exists, just try another. This will always work, but if you have a board where it's mostly mines, like a custom one, then it could take a while. The better way to do this is to take a list of numbers which represents our squares. We can do this with enumerable.range, with a range of 0 to tile count. For this, you'll need to import system.linQ, which is where you'll find enumerable. Okay, now if we can shuffle this randomly, then all we need to do is take, say, the first 10 numbers to get 10 positions for the mines. This extends out and you can get as many mines as you like, and they'll never repeat as each number is only in that list once. We can do this by adding on an ordered by to our enumerable. We don't want to compare the numbers, else they'll just stay in order. Instead, if we define the ordering function just to be a random number in any old range, I've chosen 0 to 1, then they'll be ordered randomly, which is exactly what we want. We just need to call toArray to give us a nice array of ints we can work with. Now we have that, we can simply iterate with the for loop using our nummines we saved globally when we set up the game board. The position we want to set a mine at is simply the ith element from our mines position array. We then take this position in our tiles list and set the isMine property to true. Choose the way we set up our tiles, that means we'll get the mine when we click on that now. So for the other tiles, we just need to make those that surround mines have the right numbers show up. For this, we can iterate over all the tiles, setting the mine count variable. But how are we going to work this out? Let's create a new method to help us called howManyMines. This takes the tile index so we know which one we're asking about. The basic concept is that we'll start with a count of 0 mines. Then, for each neighbouring position, which we'll define with another method I'll come back to, if the neighbouring tile is a mine, then we increase our count, finally returning the count. The getNeighbours function takes the int position and returns a list of ints, which are the indices of the neighbouring tiles. So we'll start by creating a new list, which will be our return values. The difficulty is that we created our list of tiles as a one-dimensional array. However, the neighbours are based on a 2D grid. So the first thing we'll do is convert that position to a row by dividing by the width of the grid. Similarly, the column is the position modulo the width. That is, the remainder if you divide it by the width if you're not familiar with that operator. Any cells, we have 8 neighbours to check. However, they aren't always valid choices. For example, if you're on the top row, you don't want to check upwards because there's nothing there. There are lots of ways to make this function. I'm going to take the simplistic method with lots of if statements to make it easier to follow. The first thing to note is that row 0 and column 0 is the bottom left. Let's consider tiles to the north, northwest and northeast. These will be found in our 1D tile array by adding on the width to the current position to get the north square. Then the northwest and northeast are found by subtracting and adding 1 respectively. We only want to do any of this if we're not in the top row. So we'll add an if statement to check that the row is less than the height minus 1. Then similarly for the northwest element, we don't want to check this if we're in the leftmost column. So we add a check to ensure that the column is greater than 0. For the northeast, we don't want to check if we're in the rightmost column. So we add a check that the column is less than the width minus 1. This same logic applies to all the other directions. We can only go west if we're not in the leftmost column. We can only go east if we're not in the rightmost column. We can only go south if we're not in the bottom row. Southwest, we also need not be in the leftmost column. And finally, southeast, we can't be in the rightmost column. And we're done. Breathe. Let's jump back into Unity and see this in action. As you click on the tiles, you'll see that the majority of this is working now. We've got mines in there, and surrounding the mines we've got the correct values for the other tiles. Some of them also remain blank. We've got just a few things to finish off now. The first one we'll tackle is that when you click on a blank tile, you want it to expand to all the neighbours. As we know, there'll be no mines there. So back in tile.cs, in our clicked tile method, after we've clicked on a safe tile, if the mine count for this tile was 0, then we want to click the neighbours. The game manager knows about all the tiles, so we need to create this method on that object. So in our variables, let's create a public game manager. We're not going to assign this in the inspector, as the tiles are generated at runtime, so we'll need to assign this in the code, but let's just do the last bit in tile before we switch over. So we'll call game manager click neighbors and we'll pass in this, which represents the current tile instance. So over in GameManager.cs and create game board, after we add the tile to our array, we'll assign the game manager to it. Again, we can use the this keyword to reference the current instance. Now we'll create the click neighbors method. First, we'll convert the tile instance to a position in our array by looking it up using indexed of. Then we can use a for each loop to loop over the positions of the neighbors using our helper getNeighbors function we created earlier, passing in our location. For each of these, we'll call the tile's clickTile function. We previously made this public when we set it up for precisely this reason. Now back to Unity. When we click on a blank space, it expands out automatically. Amazing. Next up, we need to make it that when you click on a mine, it's game over. So back in tile.cs, we already have a section for when we hit a mine here. We need to add an extra call out to the game manager to call a game over function. Over in the GameManager.cs file, this is very simple. We iterate over each tile using a for each loop, and we call a showGameOverState method from tile.cs. What this needs to do is reveal all the remaining mines so that you can see how you did. So in the tile, if it's active, i.e. it hasn't been clicked yet, then we set active to false so it can't be clicked. And there are two options. Firstly, if it's a mine and not flagged, we show the mine sprite. Else, if it's flagged but not a mine, i.e. an incorrect flagging, then we show the mine wrong tile, which is the mine with a cross through it. Let's try that out. That was a good start. I'll drop some flags in here, 2 in the correct place and 2 in the wrong place. Then I'll click on a mine to force a game over. The mine I clicked shows as red, the correctly flagged mines remain as flags, and the incorrect flags have the red X through the mines. All working, and I can't click on anything anymore. We also need to correctly detect the winning game over state. This happens when you have the same number of spaces left as there are mines. We want the game to detect this and automatically flag everything remaining and stop you making modifications. In tile.cs, we add an extra call to the clicked tile routine when we have clicked successfully on a tile. Here, we'll call a new method in the game manager called checkedGameOver. Over in GameManager.cs, we'll create this method. We need to check if we've only got enough spaces left that everything must be a mine. So start with a count of 0 and loop over all the tiles with a for each loop, counting the active tiles. These will be the unclicked or flagged ones. If that count equals the number of mines, we've won the game. Here, I'll just log out a message to the console and leave you to create the UI experience you want. We'll then iterate over all the tiles, setting active to false. This will stop you carrying on once you've won. Final thing we want to do is add flags to any mines that are missing them. So we'll call a new method setFlaggedIfMine, and over in tile.cs, I'll create this method. All we need to do is if this tile is a mine, then we set flag to true and update the sprite. Now when you run the game, and if you're successful and get to the end, you'll get this nice log message and the remaining mines will be flagged for you. There is only one feature missing from our version of Minesweeper. That is the ability to click with both mouse buttons on a number square. If it has the right number of flags in place, it clicks on all the other tiles around it. That makes it much quicker to complete the game. Let's add in this last feature. Let's handle the click in tile.cs in the onMouseOver method. Here we currently have the code for when the tile is active, that is unclicked. So if we add an else branch here, that'll handle the case where we're clicking on a revealed tile. In this case, we want to check if both the left and right mouse buttons are pressed. Note here that we use the get mouse button rather than get mouse button down. That is because the down variant only fires on the frame it's depressed, and it's unlikely you'll press both the buttons exactly at the same time. So we use the other version which checks every frame. If that happens, we'll call a new method in the game manager called expandIfFlagged, and we'll pass the reference to the object instance. So over in GameManager.cs, we can add this method. Like with the clickNeighbors function, we use the indexOf function to find the tile location in the array. We then find the number of flags, which we'll store in a flag count by iterating over the neighbors, incrementing the counter if the tile is marked as flagged. If this flag count equals the number of mines associated with the tile we originally clicked, we click all the neighbors with our clickNeighbors function. This will click the flagged tiles, but that's fine because the logic in that method does nothing if you left click on a flagged tile. And we're done with the game logic. Let's check out the finished product back in Unity. As you can see, that as I flag things, I'm able to click both mouse buttons and this uncovers multiple tiles at once, which makes the game so much easier to complete. And that's it. The bare bones of the game are complete now. As with all the Let's Create series, I've just shown you enough to get the core game logic working. There's a few natural extensions for you to follow up with here. Firstly, adding a border to the game area. Then you can introduce the smiley face to show the game state and restart the game. And finally, the two 7-segment displays for the elapsed time and the number of mines left. I hope you found this tutorial useful in some way. As ever, the full code is available on GitHub and I put a link in the description below. See you next time.